I would like to welcome upon stage Abhik Sarkar. He is the head of ML at Cloud Structure, an expert in computer vision and optimization. And today he's going to be talking about why knowing Cython helps in understanding Python, a deep dive into Cython and PVM. Please welcome him on the stage.
Hi folks, can you hear me? Okay, so before we begin, some quick things. I'll repeat. So we are using this menti.com. Via menti.com, I'll try to interact with you. It will save us time. And it is completely anonymous. So if someone is shy in asking questions, you can just shoot there. No one will judge you. And you can ask any questions you want. Okay, cool. The other thing is everything is available. All the codes, whatever I'm showing, all the slides, it is available in my GitHub. I'm yet to upload the slides, but most of the codes are available. So it's fine if you just listen and experience the talk more. If you're in a habit of writing, it's fine, but you can still go back and do that. I'll suggest to pay a bit more attention what we are showing. Okay, and whenever you have any doubt, I will open the window in Mentimeter and you can probably write your doubts. So, and I'll check it over there. So hopefully we'll have Q&A, we'll have a Q&A after the session as well. But hopefully all your doubts will be clear before that. Okay, any questions? Okay, I think probably. So I wanted to understand what's the experience level of people. Looks like it's mostly greater than 3. And before we begin, how many of you know about Cython or have used Cython? Okay, perfect audience. Okay, cool. We are going to learn something new today. A bit about me. So I am having approximately 7 years of experience, and maybe I've learned Python in around 2014-15. So it's around 10 years learning Python. It's one of my favorite languages, and as I'm a machine learning engineer, it's my lingua franca. I work in a computer vision focused startup called Cloud Structure. We deal with a lot of CCTV videos. Okay, enough about me and let's begin. Okay, so I'll go with the summary of the talk first. So it's a philosophical thing, like more precise the mind, the more precise the decision, right? It's a philosophical thing. You need a clarity of thoughts. You need that, then you will get more results. But what does compiler say? Compiler says more precise the data type, faster the code, right? Same, but different. Okay. I'll have a lot of memes and interactive things as well. What happens when we start learning Python? The first thing that happens is, wow, this is so easy. I can do everything. You just start flying, right? Like you need to print, you just print. There are so many things available. So easy things. It's just like pseudocode, right? It's from XKCD. It's a very popular online comic, and it always happens with someone who starts with Python. Okay, but what is actually Python? What is CPython? And what is Cython? Because these three sound so similar, but they are very different. So as we know, as we are in PyCon, we know it's a high-level language, interpreted, machine learning, web development, scientific calculations, simple, readable, right? But what is CPython? So CPython it's a implementation of Python, right? So what happens is Python can be implemented in multiple languages. People implement it in Python using Python, Python using C, that's CPython, Python using Java, that's Cython, right? And it's again, it's just an implementation how you run the code, and we'll get that into the detail. What I'm talking today right now is not CPython, rather Cython. What is Cython is, it allows C-like code using Python to make your codes faster. Okay, it is, yeah. So Python process chart. So what usually happens? We start with a .py file, right? And whenever we are running .py file, I don't know how many of you have observed, there's a pyc file as well, right? And that usually goes in cache, right? And then we just mentioned Python is interpreted. Now I'm talking about compilation. we'll get slowly into the details of it. But what happens is when we are running some code, that py file is converted into byte code by a compiler and converted to pyc file. It's a way we cache it. And then that is again, if we move to C, whatever compilation we do, it's platform dependent, right? Whatever compilation we did for, say, mobile, it won't work on your laptop. It's not the same with Python. Whatever compilation we do, the bytecode, it is then the PVM's job to run it. So there is no dependency on the hardware itself. And this is very similar with how JVM works. People talk a lot less about PVM, it's not very exciting, but it's something I just wanted to highlight, that how Python works. Then once we move to Python, we'll go how Cython is different. In Cython, as you can see, the compilation stage it's basically a bit more explained in advance, and it happens before, and I'll get to the details of it, but just letting you know, the first thing is we do a parse tree generation, abstract syntax tree generation, bytecode generation, optimization, then again object generation, and then execution. So these have a series of multiple steps, and we will go through each one of them to understand what happens. But okay, like the first question is why I am trying to combine C with Python, right? Why combining it? Why doing all these things? So whenever we are building team back in the college days, so whenever you used to build teams, there used to be, like, if you are building a project, there needs to be one guy who knows PPT well, and there needs to be one guy who knows coding well, right? So you usually look for complementary skills, and this is pretty complementary. With C, it's compiled, it's static, hard to read, but it's very fast. Python is, I think, just opposite, right? It's dynamic, interpreted, easy to read, very high level. Okay, so it's kind of like this. Okay, we as a Python developer, we always want to learn C, but C is hard, right? So what's it? Okay, let's first go into the code, and slowly we'll understand what happens. Everyone with me? Okay. So in the interest of time, what we'll do is, I won't switch back and forth. I will go with the code, explain the code first, and then we'll go in the same series which we are doing here in code. Okay. So yeah, again, before moving there, we understood very high, like in a high level, how Cython works. What we'll do is, we'll try to understand it little bit more operationally, right? Not how it works conceptually, rather operationally. Cool. So again, here, py file, earlier it was converting to pyc, right? But it's .c. What is .c? Exactly, it's C, right? Using python.h, okay. And then we are converting into .o. What's .o? Correct, right? And then from .o we are going to .so. What's .so? Okay, I think we are slowly getting to it. So from .c to .object file, and then to shared object file. The reason for shared object file is we want to utilize that in Python. Okay, so this code, can someone say it is a Python code or a Cython code? It's a Python code, right? But it can also be a Cython code. The only difference is we convert the extension .py to pyx. If it's a py, it's Python. If it's a pyx, it's Cython. That's it. We didn't do any change in the code. And okay, this is the first version. In first pass, we just changed the extension. Cool. What's the next pass? Okay. The next pass is, we are adding some unique things now. Okay. The unique things is, we are adding integer types in Python, which now this is not Python, right? Now we are slowly going into the Cython territory. Now we added, okay, it's int, so it cannot, basically it says that it cannot be a string, right? So I'm trying to define slowly what things are. Again, these are the list which usually there we have set, string, dict, list, double, int. Okay, the usual Python data types, but we are just defining them, nothing else. Okay, next is now version 3. So can you observe the difference between version 2 and version 3? See the return type and cpdef. Earlier, the return type, we were not describing the return type. over here we have described the return type as well as added rather than def, cpdef. What is cpdef? Okay, cpdef, it means basically it's compatible with C as well as it's compatible with Python. Again, it optimizes us further because we even now know the return type. And then there is something called cdef. Cdef can only be called in C, so Python cannot call it. So what we usually do is we try to wrap it inside the Python, and you can see, okay, add, and inside add, it's add -cy. Again, this is a Cython code, and then you cannot call that add -cy because it's a Cython code, and we'll call add directly in Python, and we'll see how we are doing it. Okay. Okay, let's go for the code demo, right? Is it visible? Okay. There are multiple ways to compile Cython. We'll get into it, but right now we are using Jupyter Notebook, and we are just using magic of Jupyter Notebook. That's it. Okay, I'm loading the Cython, and again, all these codes are the same codes what I showed you. Okay. Something interesting is happening here. Can you see some yellow lines? There's some yellow lines, right? Okay. So what does these yellow lines mean? Now, it's kind of like a khichdi, right? Like we are in Python and we are also in C. So all the interactions once we are in C doing with Python that is being showed by yellow lines. Okay, and it's usually HTML code, and you will get that complete HTML code in my GitHub as well. So it's basically shows whatever dependency Python dependency is there in C. Okay, and okay, the thumb rule is more yellow your code, it's slower because it's going to Python again. We don't want to go to Python, we want to be in C. That's the golden rule. Okay. Okay. So we just converted like from normal to Cython. What should be the speed up? Any guesses? Yeah, you can write it as well, but okay. The speed up, okay, this is normal way to calculate the speed up. I'm just running it for 1000 times. We can see not doing anything, no code change at all, we are getting approximately 1.5 times faster. Given the fact we have just added one character, 1.5x is not that bad. Okay, but next we are doing something else. What we did? We added all these data types, right? And in the beginning of the session I told, okay, the more data types we add, the compiler is happier. Okay, once we added the data type, can you see can everyone see the number? Can anyone read it out? It's 4000 times, yes. Again, it's not always 4000 times. I have chosen the example to, to grow interest inside you, that okay, 4000 is a very big number, and we'll get into that as well. But yeah, 4000 times we just added the data types, nothing else. I think then we did cpdef. Okay, now you see all the yellow lines, they are gone, but there is still one yellow line in the beginning because that is cpdef. Okay, that's not cdef. There's still one Python, but okay, and now it's approximately 6000 times faster, or to be precise 5700 times, which is still a lot. Once we remove that as well, interestingly, it becomes slower because we are calling from C, and it's not a big fan of calling C. We are calling from Python. It's not a big fan. So it first calls from Python, and then Python goes to Cython, and then again calls to C. So it does add some overhead, but it's still decent enough. But if you are doing all the computations inside the Cython environment itself, then cdef is more important. But if you are doing a lot of interaction with Python, I think cpdef will still be relevant to your use case. Okay, what did we learn today? We learned that, okay, if you make your compiler happy, compiler makes you happy. And these are some performance stats, okay, and you can see the drastic difference. And okay, again, XKCD comic, I'm a big fan of them. So I don't know how many of you build Dockers and do a lot of compilation, but I think that is a time when you just relax And for Python and for machine learning developers, whenever you are training your models, it's time to relax. Okay. Okay. So compilation. So I won't get in too much details of it, but there are certain ways. One I showed you, that's IPython notebook. One is manual, again, it's just for the understanding. All these details, how I've done each and every one of them is available in GitHub, but for the interest of time, I'm just not going all the details of it. My aim of this talk is not to make you a Cython expert, rather to make you interested to learn Cython. That's my aim. Okay. But okay, why Cython is faster? Okay, that's a fair question because it was very, very fast, right? But before we go there, this, I want an answer for this question. Just give me a sec. Okay, what is the limit of Python integers? I've given some hints here, but you have to write in Mentimeter, as mentioned, go to menti.com, write this code and you can interact with me directly. But what is the limit of Python integers? Okay, let me ask you a simpler question. What is the limit of C integers? Anyone? Some 2 to the power 31, some number around it, right? Again, machine dependent, but we know it, right? It has some limit. We do have infinities there. But what is the limit in Python? Okay, interesting. Okay, someone is saying, okay, in 64, someone is telling, okay, okay, mixed responses, but I have got one response as none, and again, you still need to have a limit. It's not none, but okay, 7 crore. Okay, that's not the answer. Okay, but yeah, interesting. Okay, same as system limit. Okay, but that's what. Okay, no, not as system limit. Its limit is tied to your RAM. Whoa, it's tied to your RAM. And here, why say I Python go home you're drunk? I'm adding a very big number to a very big number. It does it, right? A plus A. But when I'm adding that very big number, just 0.0, it doesn't. It says, okay, it's too large. Any idea why? Yeah, type is getting converted. That's partly the answer. But the major answer is, integer doesn't have any limit, but float does. I don't know what they were thinking, but it's very error prone. It's something which you just cannot, and whenever you're doing, calculations at the for loops, you don't realize these kinds of bugs. It's very less talked about. Okay, so something to keep that in mind. Okay, the biggest thing about Python is it's like everything is an object. It's a good thing and a bad thing. There can be times when it's a good thing and we are not going to discuss that. Let's focus why it's a bad thing. So when you go with a dynamic type language, there's a lot of overhead with the Python dynamic type system. It tries to gauge, okay, what kind it is. Every time whenever doing some calculations, we are doing A plus B, it will try to identify, okay, it is A, it is B, okay, A is integer, B is integer, okay, add it as an integer. But if it's string and string, it will add it as a string. But all these things add a lot of overhead, right? A lot. And that slowly and slowly makes Python slower. Because it's all doing in runtime. And I'll probably take this some very Bangalore example. So whenever you go to Bangalore and you are planning to go to office, okay, for me it's hybrid, okay, I'm not going office daily. But what I do is I'll go before, so what earlier I used to do? I used to take any road. I know 2 or 3 roads, I'll take any road, whatever road which I like, right? And then I realized, okay, traffic won't allow me. Then during the peak times, I tried predicting using Google Maps which road to take. So what do you think would be the faster approach? Maps, correct. But still, it's Bangalore. So that can only save you some. You will not get 4,000 times speed up there. Okay, but interesting fact is, the reason it maps is because you do some sort of pre-calculation. And that's what Cython is doing. All these housekeeping items, Cython is not doing again and again. Maybe that's why pronouns was invented in English language, that you don't call someone's name again and again and again. You use some reference, right? And that's what these compilers do as well. They have their own grammars. Okay. So everything essentially is an object, and this is a structure of object. We save the object reference and we save the type of the object. Again, you need to figure out the type first, and this is the basic structure. And then you can, on top of it, you can add another structure, another structure, another structure. That usually happens, right? So I'll show you some quick demo. Okay. Can you see this? Let me refresh it. So I made it in Claude. Okay. Can you see this? This is a Python number. Again, this is not numerically correct. It is mostly illustrative purposes. So don't say, okay, this doesn't exactly happen. It is mostly this happens, but the limit of those numbers are different. So when you are adding two very big numbers, so imagine because in C you have the limit, right? We just saw we are having a limit. In Python we don't have a limit. So Python internally represents all your numbers in a form of list, and that blows your mind, right? These are not different numbers, interestingly. These are the same numbers, and they are being added again and again. Okay, you can see the illustration, right? And I'll make it slightly smaller. Just give me a second. And we are just doing, okay. So basically we are storing the results. You can see there is, I don't think so you can see it. It says OB size. That's again, that's the size of the list which is storing the numbers. And that OB size is something like, whenever you are adding two numbers, internally there is a for loop which you are not even aware of. So that is where you are, losing your computation. Okay, interesting. So how does Cython solve it? Again, it's not like, I think I'm beating around the bush, but the thing is, as from the example we know that Google Maps is faster. So Cython, it does all those computations and take all those numbers and it uses pure C rather than Python objects. So in Cython, you don't actually have objects. You have pure C, and you take care of those memory. You take care of memory yourself. It's problematic sometimes, but mostly it helps you a lot. Okay, again, some interesting visualizations. I personally love visualizations. You can, people know what is GIL? A global interpreter lock. Okay, so what happens in Python is, again, it is a design decision, and I think now, but whenever we are running in Python, how it actually works is, okay, there is a GIL, and it goes from thread 1, thread 2, thread 3, thread 4. If you do a multi-threading, this actually happens. So it again makes things slower. If you want to bypass this, use Cython. So what happens in Cython? You can see, right? It's going from 1, 2, 3, 4. It acquires the lock and it runs it. Okay. In Cython environment, can you see no GIL section? You can see it, right? It's continuously running. So so you need to make a section which needs to be continuously running. Again, not very complicated code, but you need to make that a section, and you see, okay, CPU core 1, core 2, core 3, core 4, they are going again and again and again, but no GIL section is just running continuously. Okay, 4 cores, pretty good, but I think, yeah, code demo. I think I'm a big fan of code demo. Okay, can you see this? We'll come to it. We'll come to it. Let me find. Okay, I've opened so much. Okay. So I have 2 codes. Again, it's there in GitHub. Let's start with. Okay, let me clear it. Just give me a sec. Then GIL. Okay. Okay, let's wait. Any guesses how much time it will take? Again, no brownie points and no calculations there. What it does is it calculates sine, cosine, adds them up. Nothing very complicated. But it does it, I think, a million times or around that magnitude. I don't specifically remember. I was writing this just last night. Okay, so it's GIL. It's still okay. It took what? 24 seconds. And okay, the result is around 3.098, right? And this result is again is the addition of all these sine and cosines and everything. So remember the result though, okay? Let's do it in no-GIL, okay? Let's see. Oh shit, it's already done. You can see it, right? And can you see the result? Is it the same or it's different? Okay, how many of you think it's same? No one. Yeah, see, if you see first 6 or 8 characters, it's same. So many a times, you are okay with the second one, right? You don't need to be absolutely correct. You are like 99.99% correct. And that will save you more than 99 point, not 99, but maybe 90% of your time. So when you are doing more high performance task, you are okay with it. You are definitely okay with it. Okay, but I want to show you something else. Just give me a second. Let's go with no-GIL. And okay, it was pretty big number. I will add 5 here. Okay, and I'm running no-GIL. Okay, you can see the course. I need to pull it up. Just give me a second, guys. It's still 1 second. I need more. I need more time. I'll take it. Okay. Oh shit. That's the best approach. Okay, let me continue. So what I was showing you was all the cores were being utilized, and when I run the Python code, only one core is utilized. So that's the major difference of that particular summary, and you can actually see it in your own top, whatever you are utilizing, right? So again, coming quite naturally. Okay, perfect. I'll skip that and let me move to my slides. Okay. Okay. Now I'll talk something else, slightly related, not exactly. So many a times you have a dependency wherein your code is written in C, but you want to utilize that in Python. I don't know with you guys, but that usually comes up in some performance critical sections, right? So again, this is fairly C code, and this is the way you need to run it in Python without using Cython. So it wraps it in PyMain and it takes a couple of things, but yeah. Okay, so you can see the amount of code you need to write. But Cython addition is very easy. Cython addition is you just extern it from the header file and you just encode it, and you just need to take the care of encoding and you are good. So a lot of so can you guess who might be using these? Any guesses? NVIDIA is a good answer, but they do something else. But majorly all the scientific packages. Okay, so yeah, when it's machine learning, it's always pandas, numpy, and scikit-learn. Sometimes scipy. Okay, so what's the conclusion? Conclusion is this, wherein Cython bridges the gap between Python C's and C speed. I'm myself a very lazy person. I don't know whether you observed or not, but I just copied the theme from the website, right? So if you are a lazy person and if you don't want to change your Python code, but still want, as a machine learning engineer, sometimes you need to crunch a lot of numbers, and these are very temporary things, but you still do it on a large data set, say maybe a million data set or 10 million data set. You don't want to basically write C code again and again. You just want to crunch it and forget it. So Cython saves you a lot there. And Cython's this ability to interface with Python is actually why it's so popular. There are some alternatives. PyBind 11 is good. That is good as well. It is good for writing libraries, I'll say. So with libraries, what happens is all of these libraries, why they use it? Because they don't need to rewrite a lot of things. They are utilizing a lot of things directly from C. They are again utilizing some layers. Again, Torch is basically using Kublas, which is like Kublas is written in C and then Torch is utilizing it, right? So I think that's it. I have some questions. You can, I'm around. You can connect with me. I don't think so. We can use it in Django though. I don't know the specific of it. I'm not a Django ninja, so probably we can discuss. But I can let you know. Okay. Yeah. Thank you guys. Hope you enjoyed it. You can find me in abhik.xyz or abhikSARK. That handle is available in X, GitHub, and LinkedIn. Yeah. Thank you.
Thank you so much.